Hello guys, welcome back to my channel. My name is Hasan Khurram, and in this channel I will teach you programming skills in Python, MATLAB and R programming. I also teach Tableau, a data visualization tool. So for today's video, what I'm going to teach you how you can actually generate box plots in R programming using base R code using ggplot library as well. So for those of you who don't have an idea about box plot, basically a box plot is a visualization that shows the distribution of data set using quartiles. It consists of median, like what is the average value, median means like what is the middle value. Then we have first quartile, third quartile, interquartile range, outliers, minimum and maximum. So we are going to discuss that as we are going through the code section as well. Okay, so box plots are useful for understanding the spreadness and skewness of data. So if you don't have an idea about spreadness or skewness of data, I request you to go and watch my video regarding skewness and with the help of Python programming. I will put the link in the description for you. So it will also help us, box plots also help us identify the outliers in the data sets, like what are the extreme values in our data sets, and it will also help us visualize when we actually compare a set of data set with the help of box plot. What is the average distribution of data points across these groups as well. Okay, so as I have already told you that a box plot will consist of median, which is the median value, quartiles, 25th percentile and 75th percentile. We have interquartile range, which is basically like the difference between the Q3 minus Q1, and then we have whiskers as well, which extend from Q1 to minimum and Q3 to max. Okay, so like basically after like having the 25th percentile and 75th percentile, you actually define an additional amount of range that defines the whiskers. Okay, that the data with that falls within that range. Then we have outliers that actually goes beyond the whiskers as well. Okay, so that was a brief description of box plots. Let's move on and actually jump towards the practical programming section. So the library we are going to use in this tutorial is called ggplot2. We are calling this library by using this R statement, library within round brackets ggplot2. Then we are setting the seed by using this statement. This is for reproducibility, that whenever you are actually trying to generate random data, this will make sure that your data will have the same kind of values irrespective how many times this script has been run. So in order to generate data, we have declared a variable data and we are calling the function rnorm. Okay, what it actually does, it actually generates a value that follows a randomly normal distribution, and it takes a set of input argument. The first input argument is 100, that is actually means that we want to generate 100 elements. The second input argument is the mean, which we actually have defined it to be 50, and the third input argument is 15, which is the standard deviation. Now we have generated a data set that contains 100 points that follows the normal distribution, which has a mean of 100, 50 and standard deviation of 15. Now that being done, let's use a basic R code. Okay, so in order to use the R base here, we are using box plot. Okay, we are calling the function box plots and we are passing number of input argument. The first is actually the data, then after comma we are actually defining the title of the plot by using this key value pair main is equal to box plot with R, which is a string form of data, and after comma we are using y label and we are assigning the labels for y-axis, and we are also setting the color of the box plot. Okay, so this is like the base code that you can use in R to generate box plot. So this is a very simple looking box plot. We have values, we have box plot, we have median value, quartiles, 25th and 75th, and we have whiskers. Okay, now let's move on and actually use ggplot2 library. So we are calling this function ggplot, and we have this round brackets, and within round brackets always remember that ggplot2 actually takes data in the form of data frames. So we have to actually convert the data we have generated earlier into a form of data frame. So that is exactly what we are doing here, data.frame, and within round brackets we are passing value is equal to data. This will actually convert whatever the data we have into data frame. Okay, so data.frame. Then we are using aesthetic that will actually define what data will be assigned to what axis. So here we are defining y is equal to value, so it means that we want to assign data on y axis. Once we've done that, we are going to use plus sign and then define additional set of input arguments that we need in order to generate this box plot. So once we define the data and the aesthetic mapping, the next thing we have to define what kind of plot we actually want. So in this case we are setting geom_box plot that will actually generate the box plot. So here we are passing two input argument. Fill is equal to steel blue, which is kind of a color that we will want to generate or visualize, and the other thing is color is equal to black, which is like for the median line and also for the whisker line as well. Then we use addition sign. Then we will define the title of the plot by using gg title, and finally we are setting theme is equal to theme minimalistic by using this statement theme_minimum and round brackets. So this is how you define a box plot in ggplot2 library. So we have a very decent looking box plot, and we have also able to visualize the outliers as well. Okay, so let's move on and do some kind of customization to our box plot. So in order to do the customization, there are a bunch of options you can actually try. So this first statement will remain the same because the data and the aesthetic mapping will remain the same. Let's move on and actually do some modification to geom_boxplot inputs. These first input arguments remain the same, but what we actually are defining here is the properties for the outliers. Okay, these are the outliers that actually fall beyond the whiskers. Okay, so we are setting here the color of these outliers to red, and we are also defining its size to be 16. So these are the two properties we are defining. The rest will remain the same, and once we plot it, now you can see that the whiskers are being colored as red and their size is described as 16. So okay, that's it. Yeah, this is like a fine code in order to detect outliers. Like for example, you have a data set and you are able to visualize through these effective plots, like okay, these are the outliers. How you can actually extract that specific values of outliers? It is quite easy to do. First of all, we are creating two variables, q1 q3, which is the value of 25th percentile and 27th percentile. Once we done that, we will calculate the IQR rate, which is just the difference between these two values. Okay, once we done that, what we are defining the upper and lower bound. Like this is the bound like beyond which the data will be marked as outliers. Okay, so we have defined the upper bound and lower bound based on the quartile range. Okay, now that being done, this is the conditional logic we are actually applying in order to help us find those specific data points. So what we have here, like we have data. Obviously we want to take the values out of the data, and here we are creating the mapping. We will call it mass, whatever you would like to call it. Okay, so we are saying that we only want to take data that is less than lower bound, and or we also want to take data that is greater than upper bound. So this is kind of a conditional statement that we are using in order to calculate the outliers. And once we done that, you can see that we have like 10 and 5.10, which is kind of the same thing we have in this plot. Now let's move on. Earlier in this tutorial, I actually told you that we can use the box plot to actually compare the distribution between amongst groups. So that is exactly what I'm going to show you right now. So suppose we have like 3 groups, and these 3 groups have different kind of data. So in order to produce distinguished data, what we are using rnorm function. We are using the same number of elements, but for the mean and standard deviation, we are using different kind of values, so we can have a different group of data as well. So like for one we have 50, we have 10, for the other one we have 60 and 12. Now that being done, the next thing we have to do is actually to convert that data into a data frame. So here's a kind of a tricky one. So we have defined a variable df, then we use data.frame. Okay, that will ultimately convert it to data frame. So we are creating two columns. The first column is values, the other column is group. Okay, so here we are using this C function that will ultimately combine these elements into a single column. So we have like 100 values, and then after that 100 values of the group 2, and after that 100 values of the group 3. Now we have like approximately 300 values, rows and one column. Now what we are here doing, we are using the same logic that we are combining group 1, group 2 and group 3, and we are repeating each group value 100 times. So in the same way we have like group 1, group 2, group 3. So basically it will be now a data with two columns. One is the values and one with the group assignment, like it belongs to group 1, group 2 and group 3. After we have formed our data frame, we are going to use ggplot function. First of all, declare the data frame or data, which is in our case def. Then we have defined the static mapping. So we are using AES, and then within round brackets we define the x and y in the value in the form of key value pairs. So the x will be group and y will be the values, and we are passing an additional input argument fill is equal to group. So it means that the box plots will be colored based on the group category. So every group will be colored differently. Now that being done, we are using then addition sign and calling function geom underscore box plot, then gg title, the x label, y label, and finally theme analytic. So this is a good looking box plot we have that will help us actually to identify that kind of distribution we have in each group. So I hope this tutorial have been helpful. You were able to learn how to generate box plot, and I also tried to cover a bit of the theory of box plot as well. So if you have any questions regarding today's tutorial, feel free to write down your comments. I will be happy to help you all. And I also offer freelance services to help you tackle your data science projects and give you live consultation through one-to-one Zoom meeting. So if you are into that kind of stuff, feel free to write down your comments or contact me on my Facebook or my website. Till then, peace out, have fun. Thank you.